Here's a step-by-step guide to help you get experience with behavior-driven development, BDD, using SpecFlow, which is the most widely used BDD framework in the .NET ecosystem. What is SpecFlow? SpecFlow is a tool that brings the BDD paradigm into the .NET world. It allows developers and testers to write tests in natural language, Gherkin syntax, and integrates with Visual Studio. SpecFlow makes it easy to automate acceptance criteria for testing, providing better collaboration between technical and non-technical stakeholders. 1. Understanding BDD and SpecFlow behavior-driven development. BDD is a software development process that emphasizes collaboration among developers, QA, and business analysts. It uses a shared vocabulary to describe how software should behave from a user's perspective. SpecFlow is similar to Cucumber in the way it uses Gherkin syntax to define behaviors in feature files, but is designed for the .NET ecosystem. Gherkin syntax, the language for writing feature files, i.e. given, when, then. 2. Setting up your environment. Step 1. Install Visual Studio. Download and install Visual Studio. https://visualstudio.microsoft.com, the IDE required for SpecFlow development. During installation, select the .NET Desktop Development and ASP.NET and Web Development workloads. Step 2. Install SpecFlow extension in Visual Studio. In Visual Studio, go to Extensions, Manage Extensions. Search for SpecFlow for Visual Studio and install it. Restart Visual Studio if necessary. Step 3. Create a new .NET project. Open Visual Studio and create a new project. 1. Go to File, New Project. 2. Select Unit Test Project, .NET Core or .NET Framework, based on your environment. 3. Give the project a name, e.g. SpecFlow BDD. Step 4. Install SpecFlow NuGet packages. Right-click the Dependencies node in your project in Solution Explorer, and select Manage NuGet packages. Search for and install the following packages: SpecFlow, SpecFlow.NUnit, or SpecFlow.XUnit if using XUnit as the test runner, SpecFlow, Tools.ms build. Generation for generating code behind files. Your Xproj file should now include SpecFlow dependencies. 3. Writing a feature file in Gherkin. Step 1. Create a feature file. A feature file contains scenarios written in Gherkin syntax, describing user behaviors. To create a feature file, 1. Right-click the Features folder in your project. 2. Select Add New Item SpecFlow feature file. 3. Name it login.feature. Example of a feature file: login. Feature Gherkin feature, user login scenario. Successful login with valid credentials given. The user is on the login page when the user enters valid username and password, then the user should be redirected to the dashboard. Given describes the initial context, precondition. When represents an action or event. Then describes the expected outcome. 4. Implementing step definitions. After writing your feature file, the next step is to implement step definitions. These are methods in C# that map the Gherkin steps to executable code. Step 1. Create a step definition class. Right-click the step definitions folder and add a new class named loginsteps.cs. Step 2. Implement step definitions. For each step in your feature file, you'll write a corresponding method in the step definition class. Example: loginsteps.cs # using techtalk.specflow. Namespace SpecFlow BDD. Step definitions. Binding public class loginsteps. A given at the user is on the login page. Public void given the user's on the login page. // navigate to login page, UI interaction or API call. Console.writeLine. User is on the login page. When at the user enters valid username and password. Public void when the user enters valid username and password. // enter valid credentials. Simulate input. Console.writeLine. User enters valid credentials. Then at the user should be redirected to the dashboard. Public void then the user should be redirected to the dashboard. // verify user is redirected. Assertions. Console.writeLine. User is redirected to the dashboard. Binding. Marks the class containing step definitions. Annotations. Given, when, then used to match steps in the feature file. 5. Running your test. Step 1. Test runner, NUnit/XUnit/MSDist. SpecFlow integrates with common .NET test runners like NUnit, XUnit, and MSDist. Ensure that your project is configured with one of these frameworks, e.g., SpecFlow.NUnit. To run the tests, go to Test, run all tests from the Visual Studio toolbar. This will execute the steps defined in your feature files. Step 2. Checking test results. After execution, check the Test Explorer in Visual Studio to see the status of your tests, pass/fail. You can view details of failing tests to troubleshoot or correct issues. 6. Refactoring. Using Page Object Model (POM). To maintain cleaner test code, implement the Page Object Model (POM). This design pattern separates the logic of interacting with web pages from the test steps. Create page classes that represent the UI components and actions for a specific page. Example: login page.cs # public class login page, public void enter username, string username, // code to interact with username field, public void enter password, string password, // code to interact with password field, public void click login button, // code to interact with login button. Refactor your step definitions to use page objects. Refactored step definition: loginsteps.cs # login page equals new login page. When at the user enters valid username and password. Public void when the user enters valid username and password. Login page, enter username, test user. Login page.enter password, test pass. Login page.click login button. 7. Data-driven testing with SpecFlow. Step 1. Using scenario outline. SpecFlow supports scenario outlines for data-driven testing. This allows you to run the same tests with different sets of data. Example: login. Feature Gherkin Scenario Outline. Login with different credentials given the user is on the login page when the user enters username and password. Then the user should be redirected to the dashboard examples. Username password user 1 pass 1 user 2 pass 2 step 2. Implement step definitions with parameters sharp when at the user enters dot asterisk and dot asterisk. Public void when the user enters credentials. String username string. Password. Login page dot enter username username. Login page dot enter password password. Login page dot click login button. The dot asterisk captures parameters from the Gherkin scenario. 8. Using hooks and SpecFlow hooks are methods that run before or after scenarios, providing a way to set up or tear down resources. Step 1. Defining hooks. Use the before and after attributes to set up resources or perform cleanup actions. Example of hooks. Sharp binding public class hooks. Before scenario public void before scenario // code to set up resources. ed open browser console.writeLine starting the browser before the scenario. After scenario public void after scenario // code to clean up resources. ed close browser consult writeLine closing the browser after the scenario. 9. Integrating with CI/CD pipeline. Step 1. Using Jenkins or Azure DevOps integrate SpecFlow tests with CI/CD tools like Jenkins or Azure DevOps to automate running tests after each code commit. Use a pipeline to automatically build the project, run tests, and generate reports. Step 2. Publishing test reports. SpecFlow generates reports in formats like HTML or JSON. You can integrate them into your CI/CD pipeline to publish results after every build.